Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths. And in this video I'm looking at Pure Mathematics 4 Chapter 5 Differentiation, and I want to just touch on rates of change. And we should know that you can use the chain rule to connect rates of change in situations involving more than two variables. And when I say more than two variables, I mean you could be given area in some question and even the radius or dimensions in a different format or in a different equation. So you should be able to combine the two and let them give you the rate of change of one in terms of the other. For example, in example 6, we are told that given that the area of a circle A centimeter squared is related to its radius r centimeters by the formula A is equals to pi r squared, and we know this is the formula for the area of a circle, and that the rate of change of its radius in centimeter per second is given by dr dt, which is equals to 5. dr dt is 5. Find dA dt when r is equals to 3. Now, the rate of change of the radius with time is given by the rate of change of radius with time is 5. Find the rate of change of the area with time when the radius itself is equals to 3. And one thing you must note, you have to line up what you have. For example, we have the area, which is pi r squared, and definitely we should be able to know that the dA dr is equals to 2 pi r. That is dA dr. And because we are supposed to calculate the dA dt, I'm assuming that, or it is very clear that dA dt is going to be dA dr, which we can have easily according to this equation, times dr dt. And of course dr dt is given such that dr will cancel out with dr and you will be left with dA dt. Having said that, now using this we have dA dt is equals to dA dr times dr dt. That we know. The only thing we need to do here is simply substituting what we have, and we say dA dt is equals dA dr, which is 2 pi r, times dr dt, which is given in the question, which is 5. And of course this becomes now 10 pi r. That is dA dt. So when r is 3, when r is equals to 3, then the rate of change of the area with respect to time is going to be 10 pi times 3, which is easily 30 pi. And that is the result to that particular question. So once again, it is important that you understand exactly how it's moving out. The chain rule is very helpful here. We have talked about so much of this is the chain rule. It is so much useful here. So don't leave it behind and don't forget what we used to do when we are using and applying chain rule. Okay?